So the next part for module number 3 grammar is the normal forms of context-free grammar. Productions in G satisfying certain restrictions are said to be in normal forms. So productions in G which are satisfying certain restrictions, we say that they are in the normal form. There are two normal forms for a context-free grammar: Chomsky Normal Form CNF and Gabriel Normal Form GNF. Chomsky Normal Form, that is the CNF. A context-free grammar CFG without epsilon production is said to be in CNF, Chomsky normal form, if every production is of the form A gives BC where ABC belong to a variable and small a gives small b where a belongs to a variable and small a belongs to a terminal. So what is Chomsky normal form saying? That in the RHS, either you can have two variables, that is non-terminals, you can either have two non-terminals or you can have one terminal symbol. So in the first example, A giving you BC, we have two non-terminals in the RHS, and in the second, A giving small a, we have one terminal in the RHS. So either you can have two non-terminals in the RHS or you can have one terminal symbol in the RHS. Then only we say that it is Chomsky normal form. The grammar should have no useless symbols. Every CFG context-free grammar without epsilon productions can be converted into an equivalent CNF form. So algorithm for CFG to CNF conversion. First step is eliminate epsilon productions, unit productions and useless symbols from the grammar. So step number 1, eliminate epsilon symbols, unit productions and useless symbols. The way we were doing to simplify the grammar, same step has to be followed up. Step number 2 and 3 are the additional steps which have to be followed, which we were not following for simplifying of CFG. So step number 2 is every variable deriving a string of length 2 or more should consist only of variables, that is every production of the form A is giving you alpha with alpha greater than equal to 2. Alpha should consist of only two variables. So wherever you find that alpha is greater than equal to 2 means, suppose A giving you B, C, D, if this is the form, then this is not allowed because only two variables are allowed. Then what we'll do, we will divide this. We'll go on dividing this and only we want two variables in the RHS. So consider production. A gives V1, V2, A, V3, B, V4. Terminal symbols A and B can be removed by rewriting the productions as A gives V1, V2, A, V3, B, V4 as A gives V1, V2, CA, V3, CB, V4. So first you eliminate the terminal symbols. What are the terminal symbols? Small a and small b are terminal. Adding two productions, CA giving you small a and CB giving you small b. Next step, of every production deriving three or more variables can be broken down into a cascade of productions with each deriving a string of two variables. So whenever you have A giving you a cascade of symbols, that is x1, x2 till xn, we want how many? We want only 2. So we will divide it as A giving you x1, c1, then this c1 giving you x2, c2, c2 giving you x3, c3, c3 giving you x4 till whatever you have the cn, you have to go on doing it till cn minus 2, giving you xn minus 1 and xn up, each with two variables on the right. So how much you want? You want only two variables on the right, two variables, or non-terminal symbols, that is variables are also said as non-terminal symbols, or one terminal symbol is only allowed in the RHS, the right hand side, this side.